In today's lesson, we will be investigating integration of indefinite integrals by substitution. So integration by substitution is a way to undo the chain rule. The substitution rule for indefinite integrals says if u equals g of x is a differentiable function whose range is an interval I and f is continuous on I, then the integral f of the g of x times the g prime of x dx is equal to the integral f of u du equals uppercase f of u plus c equals uppercase f of g of x plus c, where uppercase f is an antiderivative of f. Steps for evaluating an indefinite integral using substitution. 1. Try to match up the parts of your integrand with the parts in. Take the derivative of the outside function, leaving the inside function alone, and then multiply by the derivative of the inside function. 2. Let u equals g of x, where g of x is usually an inside function in a composition. 3. Determine g prime of x and then find it inside your integrand. And write du is equal to g prime of x dx. 4. Substitute u equals g of x and du is equal to g prime of x dx to get an indefinite integral with u's in it, but no x's in it. That is, the integral f of u du. 5. Integrate. Remember to add the plus uppercase c. Very important. And 6. Substitute the x's back in and get rid of all the u's. Okay, so here are some quick, I would say, tricks for finding our u. If you have some function in parentheses raised to an exponent and then times something else out here, hopefully it's a derivative of the function that's here, that's highlighted, then your u will be inside the exponent. So when you see the word quote unquote inside the parentheses there, or inside function for u, this is what they're talking about. If you have the square root functions like and a parentheses are inside, you will look for u somewhere down here. Many times it is all of whatever is under the parentheses, and sometimes it's the radical, or sometimes it's a part of it. So you have to check based on whatever else is outside of it, what exactly should that u be. Many times it is under a denominator, just everything under a denominator, that is u. Very few times it might be up here, but most in the numerator, but most times it is in the denominator. Okay. Another thing is that it might be up in an exponent. If you have an exponential function, it is up inside of the exponent. If you have 1 over a radical something, then the u is usually located under the radical again, even in the denominator, okay? And then, lastly, if you have 1 over some denominator raised to some power, or some function raised to some power in the denominator, then the u is usually that function here in parentheses, right? So these are some quick ways of locating a u. If you say, okay, how do I find my u? These are some quick ways of locating a u. Look at a couple of examples. Determine integral x to the 5th power minus 4x plus 7 raised to the 9th times 5x to the 4th minus 4 dx using integration by substitution. First of all, we want to identify our u, or u equals g of x. This u we take to be this inside quote-unquote function, which is raised to the 9th. Right? So that's going to be equal to x to the 5th minus 4x plus 7. Please take all of the x to the 5th minus 4x plus 7. Do not just do x to the 5th minus 4x, even though its derivative would still give you 5 times x to the 4th minus 4. Please take everything, because if you take a derivative on the constant, it's going to blow off to 0. So the derivative of this will be the same as if you just took a part of it, right, with the constant. Okay, so take it with the constant. Now determine g prime of x. G prime of x, or your du, right, your du, g prime of x, right, g prime of x would be 5x to the 4th minus 4. So your du would be equal to 5x to the 4th minus 4 dx. Okay, substitute u equals g of x, and du is equal to g prime of x. So therefore, wherever you had this x to the 5th minus 4x plus 7 all raised to the 9th, we input our u. Okay, so that's u to the 9th du. So that's the integral u to the 9th du. And this is an easy integral to take. Now, this is a power function. You raise up 1 and then divide it by that exponent. So it's going to be u raised to the 10 over 10 plus c. Do not forget to add the plus c. And so in your last step, you back substitute, or someone might say resubstitute the x's, or substitute the x's back. So you replace this u with your x's. So your final answer will be x raised to the 5th minus 4, x plus 7, all raised to the 10th over 10 plus c. Example, integral sine of 3 to the x, 3x plus 5 dx is equal to, we don't know what yet, we have to identify a u. In this case, identifying our u, so steps to identify u, take the u to be this inside part, that's 3x plus 5, then du will be equal to 3 dx. And what I love to do also is to write an expression for the dx. In this case, it's going to be equal to du over 3, and then I'm going to put all of this du over 3 back into the expression, and so that helps. All right, so we're going to make this now equal to sine of u, replacing the 3x plus 5 with u, and then by du over 3, and then by our constant multiple idea, we can pull the 1/3 to the left of the integral sign, so it becomes 1/3 integral sine of u du, and so the integral of sine was negative cosine, so then this is equal to 1/3 negative cosine of u plus c. Okay, so then in our last step, we have to what some call back substitute, or substitute back the x's, the x for u. So replace your u now with the x's. So then your final answer will be negative 1/3 cosine 3x plus 5 plus c. The integral, find the integral of negative 5 e to the x over radical 1 minus e to the 2x dx. Now, let us pick a u. We might want to think of taking all of this 1 minus e to the 2x as our u. But if you try that, you're going to run into some difficulties after you take the derivative. You're going to find some extra 2 hanging out there. So you can go ahead and try that, but you're going to find an extra 2 hanging out there, which you can't get rid of. So let's try a different one. Let's make u equals e to the x. Let's make u equals e to the x. And so du will be equal to e to the x dx. So dx will be equal to du over e to the x. And then just substitute back in your u's and replace your dx right there. So then this expression now will be equal to the integral negative 5 e to the x over radical 1 minus u squared times du over e to the x. And then we want to simplify this down a little bit. And so notice here your e to the x is going to cancel out. And so this will be equal to integral negative 5 over radical 1 minus u squared du. By a constant multiple idea, you can pull the negative 5 to the left of the integral sign. So that becomes negative 5 integral 1 over 1 minus u squared du. And remember now from your ideas of integration, 1 over 1 minus u squared, radical 1 minus u squared, that would be equal to, when you integrate that, that would be arc sine of u. So we have now that would be equal to negative 5 arc sine of u plus c. And in your final step, you replace your u's with x's. So your answer will be negative arc sine of e to the x plus c. Now I want to tell you something more about this problem. This problem, if you had just pulled the 5 out and leave the negative to the 1, then you would have had a slightly different variation of the answer, but it's still a correct answer, where you would have 5 arc cosine e to the x plus c. So if you did it that way, 5 arc cosine e to the x plus c is also a correct answer, right? Let's look at another problem. In some cases, we have to do a rewrite if the integral that we're doing is not so like directly easy to just find a u and a v from. Not a v, a du from. Okay, so for example, integral of 5 cotan of 4x dx. Okay, so we might want to rewrite this cotan as cosine over sine. So then this becomes the integral of 5 times cosine of 4x over sine of 4x dx. So then let's choose our u. Our u will be equal to sine of 4x, because take the denominator in this case. And du then will be equal to cosine of 4x dx. So then dx will be equal to du over cosine of 4x. And then plug that back in, replace the sine of 4x with u. That becomes equal to the integral of 5 cosine of 4x over u times du over cosine of 4x. We like when things cancel out really nicely, so these go. And so we are left with 5. 5 can be pulled to the left by the constant multiple idea. So let's pull 5 to the left of the integral sign. So that's 5 times integral 1 over u du, 1 over u du. And so then we know then that is equal to 5 times ln of u plus c. And then finally replace that u with sine of 4x. So our final answer will be the equal to 5 times the ln, absolute value of sine of 4x plus c. And we are done. Thank you so very much for watching. Please like and subscribe, and see you next lesson.